Hello, I am Patrick Brown and I am a PhD student at Duke University in the Division of Earth and Ocean Sciences. And this is going to be a three-part video series on global temperature variability and specifically what causes global temperature to change from year to year and from decade to decade. So first of all, why do we care about global temperature? And when I say global temperature, what I mean here is taking an average of the air temperature across the entire surface of the planet. So why is this measure an important thing to care about? Well, for one thing, global mean temperature, or global average temperature, tends to be the single most recognized measure of human impact on the climate. So even the term global warming basically tells us this, that when global temperature goes up, people recognize that a lot of that has to do with human activities, and so global temperature tends to be an important measure of humans' impact on the planet. And then so going along with that, short-term changes in global temperature are very powerful in terms of how they influence public perception on the severity of global warming. So just to take recent temperature trends as an example, here are a couple articles with contradictory claims being made. The one on the left says, global warming stopped 16 years ago, Met Office report reveals, and here's a graph of temperatures being flat since 1997. And then here's another article that says the pause in global warming is not even a thing. All signs point to an acceleration of human-caused climate change. So why all this talk of a pause? So these two articles are coming to very different conclusions about what's going on in global temperature. But I'm just showing these to make the point that people care a lot about short-term changes in global temperature, and it has the power to influence the way people think about how much human activity is affecting the climate. So the point of these three videos will be to better understand global temperature and why it changes, and to be able to then read articles like these and basically understand what's actually going on behind the scenes, and so that you can better judge for yourself whether or not articles like these are making correct or incorrect claims. So the three videos will be split into three general topics. The first topic in this video will be the difference between global and local temperature. Then the second video will be on the causes of global temperature change. And the third video will be on the specific pause, so-called pause in global warming. So first, the difference between global and local temperature. So I want to set this up with just a very basic thought experiment. And the thought experiment goes like this. Here we have a kind of cartoon version of the Earth. We have some continents and we have the ocean. And let's say that you live here. You just live in this dot right here, because nobody, of course, lives in the global average. Everyone just lives in one spot on the surface of the planet. Now, let's say that there is a cold air mass to your northwest, 30 degrees Fahrenheit. And let's say that there's a warm air mass to your southeast, 70 degrees Fahrenheit. And let's say that the entire rest of the surface of the planet is 50 degrees Fahrenheit. Now, let's say that the cold air mass and the warm air mass have about the same area. And so if you average 30 and 70 together, you get 50, and the rest of the surface of the planet is 50. So that means we have a global average temperature of 50 degrees Fahrenheit. Okay, so in the real climate system, air is constantly moving around. I mean, that's what wind is, and that's why we have weather in the first place. And so we can expect these air masses to move around as time goes on. So let's say that the cold air mass goes to the south and the warm air mass goes to the north, which is what happens in the real climate all the time. Alright, so what just happened at your location as that warm air mass moved over you? So you went from 50 degrees, then into 70 degrees, and then back down to 50 degrees. And now this cold air mass moves over you. Now you're down to 30 degrees. So your location just experienced huge changes in temperature, very large swings in temperature. But what happened to the global average temperature over that time? Well, nothing, right? So it still remained 50 degrees on average throughout the entire time because all we did was move the air masses around. And so that's really why we can get these kind of large changes in local temperature, which are not representative of what's going on in the global average temperature. So just to kind of drive this point home, this is something that happened where I am in North Carolina this winter. This is just one of many headlines talking about the kind of extreme winter that we had in North Carolina this year. And if we look at the actual data, this is temperature difference above or below normal for January 2014. And you see that the east coast of the United States and North Carolina saw some of the most below normal or below average temperatures of anywhere on Earth. So it was the coldest on the east coast of the United States relative to the average temperature in January 2014 compared to anywhere else on Earth except for maybe in Siberia here. And so this serves to make the point that local temperature is not global temperature, because globally January 2014 was the fourth warmest on record. You can see that there's a lot more dark reds, which are above average, than dark blues, which are below average. So any given location can experience kind of way below average temperatures in spite of the globe getting warmer, or in spite of having a very warm global average temperature, just because of the randomness of warm and cold air masses moving over any given location for a short period of time. So that's kind of the difference between global and local temperature. And in the next video, we will talk about the causes of global temperature change.